circuits improve the quality of signals generated by transducers before they are converted into digital signal by the PC's data acquisition hardware. This is physical systems generate the signal. This is censored by the transducer or the sensor. This is a signal get from transducers. There is some noise with the signals. So after the signal is conditioning, the signal become clear. Filtering and amplifying mirrored signal from sensor is we often do this to the signal. Signal conditioning. Signal conditioning. Signal conditioning conditioner accepts the electrical output of the transducer and transmits the signals to the comparator in a form compatible with the reference input. The function of the signal conditioner include amplification, amplify the signal, because the signal come from the sensors or transducer is very small, very small. Isolation the signal from the other noises, sampling. If we want to convert the signal from analog to digital signal, we need a sample the signal. We only need some of the value of the signal. Noise elimination. Clear the noise. Linearization. If the signal is non-linear, it is difficult to process. So we want the signal is linear. Span and reference shifting. Range. The signal range must consist with the instrumentation. Mass manipulation. And differentiation, division, integration, multiplication, root finding, squaring, subtraction, or summation. This mathematical manipulation for the signal, we can process it for the next procedure. Signal conversion. Sometimes we get the digital signal, we convert it to an analog signal, or sometimes we convert the analog signal to DC digital signal, transfer the frequency signal to voltage signal, voltage signal to frequency. signal conversion signal conversion. Buffering buffering sometimes we need to save the signal for temporary temporary after we have enough this data we transfer the data transfer data buffering digitizing and change the signal code from some kind of code to another code digitizing filtering filtering clear the noise clear the noise impedance match sometimes if we connect the signal to other device we need the impedance is matched to the device for example if we want to input some signal to another signal we hope the input impedance is small input impedance is small wave shaping make the shaping is more more shaping phase shifting make the phase is with the same phase in the digital control system many of the signal conditioning function listed here also can also be accomplished by software so many conditional can be done by software and here is some example for signal conditional filtering electronic filters are circuits which perform signal processing of function especially to eliminate unwanted frequency and or enhance wanted ones enhance wanted one eliminate unwanted frequency this is for example no pass signal filter no pass signal from here can pass high pass filter the signal higher than this point can pass it's a band pass this is a notch filter here cannot pass here cannot pass here can pass filtering this is a low pass filter example low pass filter example RC resist and capacitor no pass filter if we get the transfer function for this circuit way out to way in we get the this is the function its function can pass the no frequency no frequency and prevent the high frequency amplification expands the range of the transducer signal so that they match the input range of the AD transfer For example, an X10 amplifier maps the transducer signals which range from 0 to 1 voltage into the range 0 to 10 voltage 10 way before they go into the AD transfer before they go into the AD converter This is a application for the amplifier. This is a inverting amplifier. It's the relationship between way out and the way in. Way out is equal to way in. If RF this resistor is equal to this resistor we can get the way out equal to minus way in So the way out and the way in is different in the sign. The sign is different. So we call the inverting amplifier. This is a voltage follower used to repeat a signal without loading down the sensor. It's used to repeat a signal without loading down the sensor. This way in is equal to way out. So we call this voltage follow. Way in is equal to way out with way out. This is an example of for using the voltage follow. For example, loading effect. As the example, for example, this is a sensor. This is a controller. This is sensor controller. This is sensor get from the sensor, send the sensor to the controller. If we just connect to the signal to the microcontroller, the signal from generated from the sensor is 5 voltage. And if we just connected the signal to the microcontroller, the voltage before the controller is 0.45 V. 0.45 V. This is circuit is equivalent to this circuit. This is 5. This is 10 k ohms. This is 1 k ohms. So here is the voltage is 0.45 V. So if we want to choose the voltage inputted to the controller is 5. we need put the voltage follower here. Voltage follower here. So here is 5. Here is 5. Here is 5. This is a difference amplifier. Difference amplifier. This is VA. This is VB. This is V out. V out the relationship between VA VB is here. So if RF is equal to RA, the V out is equal to VB. Subtract VA. So we call the difference amplifier. This is a instrumentation amplifier. Amplifier with a very good CMRR, common model rejection ratio. Common model. The signal come from the common terminates. We call it the common model. Common model rejection ratio is the ratio of amplified signal to amplify the noise. If we use this amplifiers, this circuit can reject the noise. So we call the common model rejection ratio. If this value is big, reject more noise. Reject more noise. This for this amplifiers, the key image for this amplifiers, we need to know the relationship for the input and output. Integrate circuit. Integrate circuit. Output voltage is proportional to the area and signal curve. This is integrated circuit. The way out is equal to here. It's differentiate circuit. Way out is equal to this. This is we call the differentiate. Differentiate. This equation is a differentiate. Active no pass fields. Active no pass fields. It's circuit can only pass the no frequency. Next, I introduce the ground loop. This phenomenon. Ground loop. Source and node should not be separated grounded because difference on potential at each ground point will create a ground loop of current node. This is sensors. This is amplify. If we transfer the signal from the sensor to amplifiers, we can connect the signal to the ground from the separate point. Separate point. There is a voltage between the two ground point. Ground point. So we need to connect the two ground point together. Ground point together. Best solution for connecting to ground earth is one end grounded at one end. No ground loop. No ground loop. There is a ground loop. There is a ground loop. Isolation circuit. Isolation circuit. Allow for two circuits to have different source voltage and ground. Isolation circuit includes ground isolation, signal isolation, and spark protection. Spark protection. Ground isolation. Ground isolation. Just connect the device. The shells. The device shells to the earth. To the earth. So this the device, inside the device is shielding by the shelter. Ground isolation connected to the earth. Connected to the earth. Signal isolation. Signal isolation. We can isolate the signal from the high voltage to the no voltage. No voltage from the high frequency to the low frequency. Spike protection. Spike protection. Protect the circuit in case the very big voltage or very big current. Very big current. Grounding. Grounding isolates. Grounding isolates. Single point ground should be used to prevent ground loop. Ground loop problems. Ground loops. Best choice is to use a single point ground at the controller. At the controller. This is circuit, and this circuit. This is and the microcontroller connects to one point, and then the single point is connected to ground. One single point ground. Single point ground. When a single point ground cannot be used, an isolation circuit with individual ground should be used. This circuit connected to one point and then to the ground. If no shared connection between the two parts, here is no connection. So we connect to this to ground. But before the two parts, we need isolation circuit. Signal isolation. Signal isolation. This is shielding can change magnetic field such as from AC lines, machinery or data lines can induce voltage into other lines. Shielding cannot block the magnet field noise, but can draw it away from the signal Y. This example, this is a signal Y. Outside the signal Y, we put the shield. So the signal is the magnet field noise can pass outside the wire, the conductor outside the wire. This is another example. There is a high voltage. There is a zero voltage. If the wire pass through the two parts, there is a voltage. Maybe 50 voltage. 50 voltage. So if we put the shield into the ground, put the shield into the ground, the voltage will zero. Magnetic electrical field can induce voltage into the shield, which will produce its own electric field. Grounding the shield will prevent voltage build up. Grounding. Transformer coupled. Good for modulated signal. Good for modulated signals. Slow changing DC signals must be modulated to magnetically coupled the transformers. For the DC signals, if we want to long range transfer, we need to modulate the signal to the the suitable forms. We can use it. This is the input signal. Use the AM modulate. We change the add the signal to the like this. This is the signal we want. This is a carry wave. This is a carrying wave. So send the signal to the another device. This demodulate can attract the slow moving signal from the AM signal. Digital opt coupler. Digital opt coupler. If we want to isolate the signal, we often use it the opt coupler. This is a signal from the outside. When the signal come here, the LED is lighted. The LED is lighted. So the light make this circuit is pass. Circuit is pass. provide the isolation of TTL level voltage, TTL voltage voltage, also called optical isolators, optical isolators. Interfacing of high voltage noise, high voltage noise systems to a controller. Signal transfer in only one direction. If the signal come the one direction from this, we can use it this optical coupler here connected to the microcontroller, here connected to the outside devices, outside devices. So if there is some spark or some error, some extremely high voltage, the voltage cannot affect the controller. So this optical coupler for the use it for isolation, Optical linear single isolation, optical linear isolation, optical linear. The isolation we use it is affected by temperature or something else. The signal, the output signal is non-linear. It is non-linear. So we change the optical coupler to the linear signal isolation. Add the feedback. Add the feedback. Add the feedback in the isolation. So change the non-linear signal to linear signal. An LED and a matched photo transistor are used to provide the optical isolation. LED. This is the LED. Photo transistor. This is the photo transistor. I used to provide optical isolation. The feedback photo transistor provides the feedback due to nonlinear response of the LED. If the response is nonlinear, the feedback transistor can make the signal become linear. So if the signal come from here, we can get the linear signal here. Calibration. The sensor manufacturers usually provide the calibration curves. If the sensors are stable with no drift, there is no need to recalibrate. However, Often the sensors may have to recalibrated after integrating it with the signal conditioning systems. This essentially requires that a known input signal is provided to the sensor and its output recorded to establish a correct output scale. This process proves the ability to measure reliably and enhance the confidence. If the sensor is used to measure a time-varying inputs, dynamical calibration becomes necessary. Use of use of sinusoid inputs is the most simple and reliable way of dynamical calibration. Another test is looking at the transient behavior of step response. Summary. Sensors and transducers are essential elements in mechatronic systems because they are used to measure the controlled variable and transmit to the controller as feedback. The sensor can be divided according to the variable that's the measure. Position, velocity, acceleration, force, torque, pressure, flow, temperature, proximity, and range, for etc. We have already introduced all the sensors. We just introduced some sensors. We can use it in the mechatronic systems. Last semester, we learned something from for the microcontroller. So the microcontroller can get the signal from the sensors and calculate the signal and output the control signal. So we can use the sensor as the feedback. This is the end of this chapter for the sensor. This is the end for this chapter. Everyone? Everyone? Hello? 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 Anyone can hear me? Oh, okay. I meet you. Let's have a break. Let's have a break.
推开叶晨，娇羞地说道：“
好弟弟，看你猴急的样子，要不要姐姐现在就给你啊？”
说着，他脱掉外套，只穿着一层薄薄的半透明纱料衬衫，一条腿跪在床边，一只手挑起叶晨的下巴，一脸妩媚地盯着他。这一连贯的动作，就算是自认脸皮非常厚的叶晨，也感觉有些 hold 不住。你在问我，知道吗？上官微微咯咯一笑。
怎么，好弟弟要把持不住了吗？姐姐现在给你，你敢要吗？
你以为我不敢？说着，叶晨猛地一下搂住上官微微，狠狠地吻了下去。既然这个妖精一进来就开始勾引自己，不给他一点教训，实在是有失男人的面子。几分钟以后，叶晨一脸懵逼的感觉身体脊梁一麻，嘴里发出低沉一声，老脸通将上官微微推开。狼狈不堪的叶晨直接冲下床，钻进卫生间。被推开的上官微微感到身体一阵的空虚，一脸潮红，还未褪去，几乎能滴出水来，又好气又好笑的自言自语：“
你这个小死狼！”
叶晨想死，自己明明已经不是处女，竟然就这样爆发了，真的想拿一块豆腐撞死自己得了，觉得自己已经生无可恋，被一个女人虐成这个样子，简直生不如死，替全天下的男人丢脸。妈的，今天丢人丢到姥姥家，早晚有一天我会好好的伺候伺候。叶晨心中想法，手上却是没有闲着，拿着纸巾处理。清理好以后，叶晨犹豫，自己要不要出去？出去后，这个妖精要是继续勾引自己怎么办？太没出息了，衣服都没脱掉就已经这样了。真怀疑上官微微要是脱掉衣服，会是什么样的一个情况？深吸了一口气，叶晨整理了一下心情，走了出去。只是看到空空的病房，上官微微已经不在了。来到病床的时候，看到有一个字条，上面写着：“
好弟弟，你弄得姐姐好难受，姐姐先走了，不要太想我。”
看着纸条上面的内容，叶晨有种想哭的冲动。这个妖精还在刺激自己。其实上官微微也好不到哪儿去，他事先只是想调戏一下叶晨而已，谁想两个人会擦枪走火，而且叶晨竟然交枪投降。走出医院的时候，脸上朝霞未退，媚态横生。叶晨看到这种模样，恐怕还是会受不了。叶晨坐在床上，被子上还残留上官微微身上的香味，这倒是让他有些心旷神怡。回想刚刚的刺激，让他有些苦笑。在叶母的强烈要求下，叶晨硬生生的在医院待了2天。这2天的时间差一点将他逼疯，主要是上官微微那个妖精时不时的就要来调戏一番，这让叶晨非常的郁闷。除了这件事情以外，每天晚上睡觉的时候，他都会做梦。那个于心蕊到底是一个什么人？自己跟他有什么关联？想不通。离开医院以后，叶晨将自己关进屋子里，祝由术的一些内容已经灌入他的脑海，他想研究一下，只是没记忆的时候，脑袋就像挣扎一样，不得不让他放弃。突然，那个老太婆的声音在叶晨的内心深处响起：“
看病不要看表面，有些东西不是针灸和汤药就能治好的。”
到底是什么意思？现在叶晨真的好像再见到那个老太婆。想到这里，叶晨不再等他，走出去，来到第一次跟老太婆相遇的地方。我们的叶晨同学就这样蹲在那里，一边看着街上的美女，没着，一边等待着老太婆的出现。只可惜他没有见到老太婆，却是等来了肖队长。只见肖队长从小轿车走下来以后，对着叶晨笑了：“你小子在这里干什么？”他去叶晨家里找他，可是被告知叶晨已经出去了。 自己一个特别行动组的队长，总不能满大街找他。最后干脆调用人员查到叶晨的行踪。根据下面的人报道，说叶晨一整天都在这里待着，好像除了看看美女，剩下的什么动作都没有。听到这样的报告，肖队长都有点背不眼神。这个家伙竟然为了看美女这么卖力。看到肖队长，叶晨一拍大腿，暗骂自己笨。肖哥，你来的正好，有件事情求你。哦，什么事儿？能让叶晨开口求自己，肖队长很乐意笑。这意味着叶晨会记下他一个人情。我找别人，谁呀？一个老太太。叶晨说道。有照片，或者叫什么名字？肖队长问道。叶晨这才想起来，自己没有对方的任何信息。怎么着？这海这么大，上哪里去找？总在这里等着也不是办法。行了，以后再说。叶晨有些失望地说。上了车，肖队长递给叶晨一个小本子，驾驶证。你说你好歹是一个老总，弄辆车吧。叶晨看着手中的驾驶证，心中那一丝的阴霾消失，笑道：“嘿嘿，老哥，我要说我喜欢你这辆悍马，不如给我弄一辆。”肖队长嗤笑：“你小子，张口闭口跟我们要1个亿，谈到在乎我这辆车，那可不一样，你这可是军用的，每个男人都行。”叶晨说：“行，这件事情我给你想想办法。”肖队长现在对叶晨所说的话，可以说只要不过分，都会答应。经过一番分析，叶晨和肖队长来到了特别行动大队，只是这一次没有过多的逗留。肖队长带着叶晨直接来到了部队里面的一个小花园。此时小花园中，那名老人正在钓鱼。等到2个人走进去后，老人缓缓地开口说道：“你先出去吧。”肖队长递给叶晨一个眼神，对着老人敬了一个军礼。是。等到肖队长走出去以后，老人忽然转过头来，盯着叶晨的眼睛，一股军人强悍的杀气溢出来。感受到这种滔天的杀意，叶晨下意识地稳住身子，心脏一阵阵收缩。那是一种奇怪的感觉，眼前的这个老人身体并不是那么强大，但是这种气势犹如可以随时掌控一个人生死一般。叶晨体内的功法自行运转，一股强大的压力扑面而来，让叶晨说话都有些困难。这种感觉让叶晨非常的不舒服，体内的真气强行的将这股压力驱散。叶晨尽量的保持轻松的站在原地，却没有说话。老人眼睛微微一亮：“小伙子，没想到你小小的年纪就能抵挡我的气势，看来也是一名练气的人，难怪见到我这么粗。说，你师傅是谁？”叶晨愕然，什么练气？自己练的是功法？摇了摇头，说道：“在下不曾跟人学过练气，没有师傅。”老人微微皱眉，练气是一个功夫的标志，没有人领进门的话，平常人怎么可能练成气？只是他看着叶晨的神色，又不像是在说话，点头，淡淡的说道：“既然你不愿意说，也就算了。不过你这个年纪拥有这等气势，应该属于佼佼者。难道你的医术也是这么厉害？”老人收回气势，叶晨感觉身体顿时轻松不少。“老人家，我是一名医生。”叶晨简单的回答，却是让老人眼睛一眯。“好口啊的小子，言下之意，你身上的气息不值一提吧？”老人哈哈大笑地说：“任何一门行业想要精湛，必须要花大把的时间和力气。叶晨小小的年纪，能够将身体的气息调整到这等高度，显然已经不是什么普通人。这样的一个人，哪里还有时间精修医术？天才也要有一个限度，没有谁天生就可以变成天才。”虽然他觉得叶晨的言语有些狂妄，但不代 肖队长他们知道老人对叶晨是这般评价，一定会惊掉下巴。他们没有见过老人对谁有这般评价。听说你上次把秦风还有士兵给打了，难道你不怕我处置你吗？老人再一次冷着脸，淡淡的说道：“首先，我要把握治好他；其次，我想说，我并不是单纯的打他。相信老人家叫我来的目的，应该是因为杨元丹吧？”叶晨从容地说道。老人点点头，没有说话，示意叶晨继续说下去。作为一名医生，我的职责是救治伤员。作为合伙人，他们怀疑我的产品，我有义务让他们知道产品的效果。所以，老人家，你说的那个打人事情，并不是真的打人，而是让试验养颜针的效果而已。老人没有想到叶晨会这么说，愣了一下，突然大喊起来：“太离邪说！打人就是打人了，什么乱七八糟的！”显然，他并没有生气，而是觉得叶晨这个家伙狡辩的能力也很强。明明是动手打人，愣是说成试验产品。我只是实话实说而已。叶晨说。老人在笑。我已经很久没有看到这么有意思的年轻人了。你比那些兔崽子强多了。他们见到我只会夹着尾巴，鸡都不敢冲一下，没意思。老人家过去了。老人示意他过去坐。叶晨走了过去，老人却是拿起
Hello, everyone. Let's continue our class. I check your meeting name. There is at least three people. Don't change the meeting name to your student ID and the real name. I don't know who is that. Please check your meeting name. Meeting name. Next, I introduce the selection criteria, sensors and the transducer selection criteria. When we design mechanical devices, we use a transducer and the sensors. We just select the transducer and the sensor. So we need to know how to select. In this chapter, I introduce the sensor characteristics. Sensor selection and sensor comparison. Sensor characteristic difference between the maximum and the minimum value of the sensor parameter. The sensor parameter. Resolution. The smallest change. The sensor can differentiate. For digital sensors, it is related to a number of bits. For analog sensor, it is limited by no level electrical noise. Sensitivity. Ratio of change in output to unit change of the input. Ratio of change in output to unit change of the input. For digital sensors, sensitivity is closely related to the resolution. For analog sensor, sensitivity is the output snoop way as input snoop. For this example, this is the relationship between input and output. The snoop coefficient. If the snoop is high, the sensitivity is high. If the snoop is intermediate, the sensitivity is intermediate. If the no, the sensitivity is no. Sensor characteristic error. The difference between the measured value and the true value. Two classifications, bias and randoms. accuracy inversely proportional to the error, inversely proportional to the error. Sometimes related to the sensor's linearity. Accuracy and the precision, ability to reproduce repeatedly with given accuracy, sometimes called repeatability, repeatability. So we know the difference between the accuracy and the precision. Precision, repeatability. This is a difference between accuracy and precision. This is a true value. This is a true value. If the measured value is here, but this is close. This value is close. We said this is precise but not accurate. Not accurate. For this is true value. Is true value here. This is true value. This is measured values. The value is distributed between nearby the true value. So the value is not precise, but accurate, because there is some value is equal to the true value. So we said this value is accurate, but not precise. Here, there is no value is equal to true value, so is not accurate. The value is not close, so not precise, this figure, the measured value is equal to true value, and the values are close. So we call the accurate and precise. Since characteristic linearity, percentage of deviation from the best fit linear calibration curve, linearity means superposition principle. Which means only one of the output from one and the output from two is can be put together, become one and two. Most systems have linear behavior. Most non-linear behavior. Impedance ratio of voltage to current is electrical. We know the impedance is the ratio of voltage to current. Two types are input and output impedance. Input impedance measure of how much current must be drawn to the power the sensor modeled as a resistor in parallel. High input impedance is desirable. if a device used as a input device, is the impedance is high, which means the circuit is cutted. The circuit is cutted. So the device cannot affect the circuit. Cannot affect the circuit. The output impedance, since the ability to provide the current to next stage, modeled as the resistor is serial with the sensor output, is a sensor is serial, which means no output impedance is desirable, which means zero is the best. Zero is the best. This is a conception for the linearity. This is a nominal straight line. This is nominal straight line. If the signal is between the nominal straight line at 10% full scale and the nominal straight line subtract 10% full scale. If the signal is between this range, we call it is good linearity. Good linearity. Sensor characteristics. Saturation is the maximum value. The maximum output compatibility regardless of inputs just for the maximum outputs. Maximum outputs. Deadband. The range of inputs for which there is no output. The range of inputs for which there is no output. Deadband. Zero offset. Non-zero value output for no put. When is no put, we can get the output which means zero offset. Zero offset. Zero drift. The departure of output from zero value over a period of time for no input. This is for saturation and deadband. This is output. This is output. Here is the maximum output with saturation. This is a saturation. Maximum output. Deadband. Here is no output. Output is zero. So we call this is deadband. Deadband is the same. In this range. The output is the same. Cannot change by input. So this is deadband. Sensor characteristic response time. The time lag between input and output response time. Bandwidth. Frequency at which the output magnitude output magnitude drops by 3 dB drops by 3 dB this is bandwidth resonance the frequency at which the output magnitude peak occur or operating temperature the range in which the sensor performs as specified operating temperature is the device work normally device normally it's that temperature range signal to noise ratio the ratio between the magnitude of the signal and the noise as the output the ratio the signal to the noise the ratio signal to the noise if this value is big which means the noise is can be very no very no can be very no which means the noise suppressed sensor selection criteria sensor selection criteria variable measures and application variable measures and application dynamical range required resolution and sensitivity required accuracy and precision environmental conditions power available for sensing this is criteria for selection availability cost size and available space ease of use ease of maintenance required signal processing here's some sensor comparison linear and rotational acceleration torque and force and torque flow temperature proximity light smart material is comparison linear and rotational sensors this is RVDT high resolution very stable optical encoder simple reliable and no cost good for absolute and incremental optical encoder electrical tachometer tachometer resolution depends on type such as generator or magnetic picked up resolution depends on Hall effect sensor high accuracy over a small to medium range small and medium range capacitive transducer very high resolution with a high sensitivity no power required very high resolution very high resolution strain gauge element very high accuracy in small range provides a high resolution at no noise level interferometer we not listed here last listed before just give you some features about the laser systems provide extremely high resolution in large range very reliable and expensive very inexpensive in many machines we use interferometer magnetic picked up output is sinusoid gyroscope for the mounting orientation inductance is very high resolution over small ranges here in some comparison for the acceleration sensors seismic accelerometer piezoelectric accelerometer this is for low frequency good for measuring frequency up to 40% of natural frequency piezoelectric accelerometer for high frequency very high natural frequency high sensitivity compact and rugged from here we know if we want to use the acceleration sensors for the low frequency uses the seismic accelerometer for the high frequency uses piezoelectric force torque and pressure sensors force torque pressure sensors this is for the force or node force or node the strain and gauge dynamometer node cell piezoelectric node cells tactile sensor ultrasonic stress sensor its strain gauge good for static and dynamic the dynamometer available as a micro and nano sensor macro and nano sensors Piezoelectrical good for high precision dynamical tactile sensor has a wide dynamical range and high precision as a tactile. Ultrasonic stress sensor good for small force measurements good for small measurements small force measurements small force this is a characteristic for the sensor. Flow sensor pitot tube widely used as a flow rate sensor to determine the speed in aircraft orifice plates less expensive with limited range less expensive which means cheap but with limited range flow nozzle venturi tube accurate on wide range of flow accurate rotometer good for upstream flow used in conjunction with wearable inductance sensor ultrasonic type good for very high flow rates can be used for both upstream and downstream turbine flow meter not suitable for fluid containing abrasive particle relationship between flow rate and angular velocity is linear electromagnetic flow meter this intrusive as it is non-contact type can be used with fluids that are corrosive contaminated the fluid has to electrically conductive this is a characteristic for the flow sensor you can select the flow sensor for your application according to the characteristics next temperature sensor temperature sensor thermocouples this is cheapest and the most versatile sensor thermocouples the cheapest applicable over wide temperature is thermocouple thermistor thermistor very sensitivity in medium range compact but non linear in natural compact but non linear in natural non linear. Thermal dyes and thermal transistor ideally suitable for cheap temperature measurements minimize the self heating for cheap temperature measurements. RTD resistance temperature detect more stable over a long period of time compared to the thermocouple linear over a wide range. An infrared type non-contact point sensor with resolution limited by wavelengths thermography measure whole field temperature distribution which means when we want to detect many people at once we use it infrared thermography it's for temperature sensors proximity sensor inductance eddy currents Hall effects and the photoelectric capacitance this sensors robust non-contact switch action the digital output is often directly fed to the digital control this all these sensors if we want to get the digital output we sometimes use digital sensors even the only type the same type for the proximity sensor we can made it as use it as a digital output or analog output light sensors photoresistor photo diodes photo transistor photoconductor it's a light sensor measures the light intensity with high sensitivity inexpensive reliable non-connect charge coupled diode capture digital image of the field within capture digital image of field within this sensor charge coupled diode we call the CCD sensor we use it on the digital camera smart material sensor material sensor the optical fiber piezoelectric magnetostrictive optical fiber we can use it as a strain sensor, level sensor, force sensor, temperature sensor all these sensors with is a high resolution reliable and accurate concurrently. If this sensors used as strain sensor alternative to the strain gauge with wide high accuracy and bandwidth sensitive to the reflecting surfaces of such orientation and status sensitive to the reflecting surface use it as a level sensor reliable and accuracy use it as a force sensor high resolution use it as a temperature sensor high resolution piezoelectric when use it as a strain sensor distributed sensing with a high resolution and bandwidth use it as a force sensor most suitable for dynamical application use it as an accelerometer nice haste nice haste resist nice haste resist and a good set point accuracy the magnetostrictive as a force sensor compact force sensor with a high resolution and bands good for distributed and non-contact sensing application use it as a torque sensor accurate high bandwidth and non-contact sensor from here we know the smart material can use it use it as many kinds of sensors but often we use it the high resolution is high next macro and nano sensors this is wrong macro and nano sensors macro CCD image sensor small size this is CCD for the image sensor fiber scope small micro ultrasonic sensor detect flow in small pipes micro tactile sensor detect proximity between the end of catheter and the blood vessels It's macro and nano sensor used for the very precise detection very precise detection this is for sensor selection criteria this chapter for the sensor selection criteria. Okay, everyone, let's have a break. Everyone, let's have a break.
心，就是500。Let me show you again. It's from 这是1是吧？I can say this one. So when it's 9, that's 这是我第一次看到你们这样的游戏，是第一次。以后会讲，比如我刚吃饭所以吃饭。Now let me take you to one of the most challenging popular team. It's the Charging your son. So what the in fact we can say in China, if you go somewhere you find people making some you can see when you here check it. There's a big part that team. It's one
Hello, let's continue our class. Let's introduce the active H. Active H. This is a mechanical diagram. Mechanical diagram. This is a relationship between the elements. Relationship between the elements. Here is information and processing elements. Give the signal to the active H. Active H. The active H drives the mechanical the mechanism and realize the physical movement and the movement censored by the sensors and feedback to the to the central controller to the controller and this controller gives the communication to the human being and gives a operator interface have a communication with the human being as the communication with the human being. From here we know the active H receives a signal from the controller and gives the drive to the physical process we know the active H can use it as an interface between low power and high power. Low power and high power. Here is a active H functional diagram. The control signal received by the power amplification and modulation block, and this module use it as an interface, low power and high power. So converts the low power to high power and gives it to the active H. The active H transfers the energy from the electrical energy to mechanical energy. This is a active H functional diagram. Electrohydraulical and electromechanical active H. Hydraulical this use it as a power amplification and modulation. Gives the power to hydraulical drives the node. Actuate or drives are essential elements of mechanical systems. They are the muscles. That provide the mechanical movements. Actuation is the result of direct physical action upon the process, such as the application of a force. Actuators take no power signal transmitted from the computer and produce high power signal which are applied as input to the process. Actuator. The actuator, the types of actuators are electrical, mechanical, hydraulical, and pneumatical. Electromechanical, including DC motor, AC motor, and step motor. Hydraulical, mechanical, hydraulical, and pneumatical actuators. First, introduce the DC motor. The electrical motor is based on the principle that current carrying conductor will experience a physical force when in the presence of a magnetic field. The DC motor consists of a rotating armature, and a stationary magnetic field. The current in the armature, which must come through brushes, cause the rotating force. The stationary magnetic field is provided by either electromagnet or by permanent magnets. When the magnet field provided by electromagnet is called wound field motor. This is a serial of operation for the DC motor. When the current passes through the brush and to the coils, to the wire coils, the wire gets the force because of the magnetic field, and the current flow through the wire and with the brush and back to the power source. This is a serial of operation. When the wire change the direction, with the wire change the position, the current needs change. So through the brush, the current changed. This is a serial of operation for the DC motor. DC brush motor DC brush motor are suitable for a wide variety of applications, especially for positioning and speed control. They do require an encode for positioning applications. DC brush motors are available in a great variety of size, up to several kilowatts, and the speed range can be as high as 10,000 RPM. They run smoothly and relatively quiet. The major disadvantage of DC brush motor are the brush, which do wear out. Over time and needed to be replaced. This is a brush. This is a brush. When the brush is we need to replace it. Another drawback is that DC brush motor provides a relatively low torque in comparison to their size and weight. No torque comparison to their size and weight. DC motor types wound field. The serial motor has armature and the field windings are connected in serial. This type of motor is characterized by a high starting torque, and a high no node speed, but poor speed regulation. The speed change considerably if the node change. The shunt motor has armature and field windings connected in parallel. This type of motor has much better speed regulation than does the serial motor. Compound motor has both serial and shunt type field windings and combine the good characteristic of both the serials and shunt motors. However, they are more expensive and more difficult to control. This is a serial motor. Serial motor, the armature and the field connected serially. This kind of this type of motor has a very high RPM if no node if no node high torque at no PM no RPM no RPM. This is a shunt motor shunt motor the armature and the fields connect parallel connect parallel. For this kind of motor, the torque and the speed, torque and the speed are almost linear, almost linear. This is a compound motor. This is a compound motor. This compound motor has two field, serial field and shunt field, shunt field. For this kind of motor, the relationship between torque and speed is more linear. Is more linear. This is more linear. DC motor types are permanent magnet motor use permanent magnet to provide the stationary magnetic field. Stationary magnetic field. This resulting a very linear torque speed curve. Very linear torque speed curve, which makes it easy to calculate the motor speed for various node conditions. And that's attractive for control system application. Disadvantage is that the magnetic field will weaken after time, and the flux is constant. Flux is constant. For large motor, fluxes might not be appropriate. This is a permanent magnet motor. Here is a wounded field. In the wounded field, the magnet is provided by the coils field, by the coils. In the permanent magnet motor, the magnet field is provided by the permanent magnet. This is the permanent magnet motor, PM motor, this is a magnet. This is a magnet. Permanent magnet. Permanent magnet. The permanent magnet, the speed, the relationship between speed and torque is linear. The speed, current is linear. So as we know, we always like the linear relationship in the control. This is this figure about the torque and the speed and torque the speed to find the motor speed and the current for no node store condition no node store condition and lifting for example lifting a 10 ounce node with a 2-inch radius pulley radius pulley this 10 ounce this is radius 10 inch so the torque is 10 multiplied 2 is 20 20. So we know the torque is 20 so we can find the speed find the speed The torque speed curves shift by changing the supply voltage when we give the difference the voltage the curves torque speed curves just shift this curves is parallel to each other parallel DC motor example. DC motor example. A permanent motor turns a large 60 centimeter diameter. 4.5 kilogram turntable through a 20 proportion to 1 a gear twin A particular required is that the turntable must be able to accelerate from a rest position to 90 degree in second in 0.2 second. Determine the necessary motor voltage this is a procedure for the calculation First, we can calculate the torque with this equation T is equal to I alpha. After that, we can calculate the moment of initial. This is the moment initial. With the we can calculate get the moment initial I. So with this equation, we can get the torque. This is a torque 0.8 Nm. So get the result from the figure in last slide. Here. This is a torque. There is 0.8 0.8. So we can get the voltage is 12 voltage is 12. When the speed is 0 the voltage is 12 voltage is 12 DC data sheet DC data sheet when we select some kind of DC motor, we need to know the sheet for the motor for the motor. This sheet is provided by the company by the company. So if you want to select right motor, you need to check the sheet check the data sheet Data sheet provides all the needed information about the DC motor to be used. It is important for engineer to able to read the data sheet and find the needed information. The following two steps provided some example. This is a data sheet for the wounded field. This is a macro motor. This is a data sheet. So when we select the motor, we just look up the value in the data sheet. Look up the value in the data sheet, and select the appropriate motor. As we know, the disadvantage for the DC motor is the brush. So we have the brushless DC motor. Brushless DC motor use permanent magnet and therefore do not need brushes. Brushless DC motor BLDC use permanent magnet instead of coils in the armature rotator. And therefore do not need brush. The field coils are switched on and off in a rotating sequence that pull the rods around. They have built-in sensors that direct when the individual field coils are to be switched on and off. These field coils are switched on and off, to pull the rod around. They are available in a wide power range, and they can operate at very high speed, up to 30,000 RPM. They are able to generate high torque for a given size. DC brushless motor are the most widely used motor for several applications. This is a brushless DC motor. This is coils. This is coils, ABC coils. Here is a rotor. When the this rotor power on, this coil is powered on, the rotor change the position like this. When the this B coils power on, and the rotor change the position like here, like here. When the C coils powered on, the rotor change the position like this. So as we know, when the coils are powered on like this, the rotor turn round like this, This is a brushless DC motor. In the reality, we detect the rotor position. Detect the rotor position with the optical slotted coupler. Optical slotted coupler. When the this slot move to one of the coupler, the net can be censored by the coupler. So so the power is on for this coin. This coin. This is a brushless DC motor. Actually brushless DC motor. This is coins. This is coins. Coils. This is rod. This is rod. Permanent magnet. Permanent magnet. Brushless DC motor. Brushless DC motor. Advantage reliable high performance motor. High performance motor. Reliable high performance technology. Long life. Virtually maintenance free. Cooler running. Low acoustic. They run relatively smooth and quiet. They do not require mechanical brushes for commutation. That's advantage. The disadvantage high price. Due to the use of rare earth, magnetic material to generate torque. They also require fairly complex, and thus more expensive amplifier. In a summary, we know the brushless DC motor there is many advantage but the disadvantage is expensive expensive next I introduce the servo motor servo motor when we use it with the motor as the servo motor have built-in shaft encoder built-in shaft encoder a data sheet provides required params for specific speed or prediction prediction. When we use the motor as a servo motor we need to check the data sheet check the data sheet for our use this is a relation between the servo motor and the encoder this is a main controller main controller this is a electronic motor encoder this encoder building in shaft mostly we just connect the build the encoder with the motor together this is we use the motor as a servo motor just add the encoder to the motor just add the encoder to the motor next I introduce the step motor step motor basically DC brushing motor basically DC brushless motor however they do not require encoder for position feedback they rotate in fixed step as related to a number of degree Step motor produce high torque for a given size and weight. However, the available torque from step motor drops dramatically within higher speed which means when the step motor are running in higher speed the torque is no their maximum speed around 5,000 rpm at very no knock torque very no torque but hardly above the above that level the major drawback of step motor is the noise and the vibration they produced noise and the vibration is a major drawback especially vibration can affect the lifetime of a mechanical system significantly. It's a major drawback, and all the disadvantage noise and vibration. This is a two-phase step motor two-phase step motor two-phase bipolar step motor bipolar step motor There is two coils coils and this coils this is a magnetic field produced by this coin it's another magnetic field produced by these coins this is a four-phase step motor four-phase this is step motor produce magnet this produce magnet this produce magnet this this is four-phase step motor which means it has four different magnetic field Here is some figure show us the mode of operation mode of operation This is when the one phase is power on the position or the degree will change but has some vibration change vibration sometimes we use the snow mode to make the curve more smoothly This is snow mode This is direct drive this is snow mode Hello, everyone.
Hello, 老师。
Hello, 老师。
Let's finish our class for today.
Yes, 老师。Yes,
Okay, no
so
problem.
Okay,
Feel
okay.
free, 老师.
Okay, you can
Bye bye.
have rest. Okay, let's
Okay.
finish our class for today.
Okay.
Okay,
Okay, thank
老
you.
师。
See you
Bye
next week. See you next week.
Laoshi, please, PPT.
PPT I shared in the meeting. In the meeting. Okay.
Laoshi, WeChat group, WeChat.
We don't share the PPT in the WeChat because
Okay.
if you come to this class, you can have the PPT. If you don't
Okay,
come
Laoshi.
to this class, you don't have the PPT. Okay.
Okay, Laoshi.
You can download the PPT from the meeting from the meeting.
Yeah. Okay.